Good morning, dear students. Welcome to science class. I hope you all are safe and fine and preparing well for the final exams. So, today we are going to discuss chapter number 14, Some Natural Phenomena. This is your last chapter. Natural phenomena, as the name indicating that the natural disaster. So in this chapter we are going to discuss about the natural disasters like the lightning, earthquake, flood, and how we measure them and prevent from them. Natural disasters keep reminding humans of their minimal existence on this planet. Ever since the development of scientific methods, the human mind is in continuous process of understanding the cause, their effects, and the developing safety measures against these calamities. So it is very important for each one of us to understand them so that we can protect ourselves or others in need in case these phenomena occur. In ancient time, the natural happening, even like the rainfall, snowfall, flood, fire, lightning, etc., were understood as the anger of God. In this chapter, we are going to study some detail about the lightning and earthquake. Lightning. You have already seen the sparks on a loosely connected plugs or anywhere else where the electric connections wires have become loose, right? So lightning is just like that spark. Lightning is also a huge electric spark taking place among the clouds when the moisture content of the clouds become large, and this firstly discovered or understood by an American scientist, that is Benjamin Franklin, who conducted his famous kite and key experiment in 1752 and proves that lightning is nothing but just a electric spark or a huge electric spark taking place among the clouds. We will learn the chapter of force and pressure in previous classes, that there are two kind of charges, that is positive and negative charges, right? And same charges attract, repel each other, and opposite charges attract each other. And also learn that since the electrons are negatively charged available on the outer surface of the atom can be knocked off simply by rubbing two material against each other. So when we rub two things, one object becomes positively charged and other becomes negatively charged, and the charge will be equal and opposite. Means if we have 100 positive charge, then other object will have 100 negative charge. So equal and opposite charge will be created when we rub two things. So you are wondered that we started discussing lightning as the electric spark or electricity. Is there a relation between charges and electricity? Yes, you are correct. If you are thinking that actually charged bodies are stationary, means they do not move until it is touched by a good conductor of electricity. That's why it is asked that do not touch any charged object directly, as human body is a good conductor of electricity and it takes away the charge from the charged object. In fact, charge flows whenever two objects charged to different level are brought in direct contact or are connected through a metallic object. The flow of charge is always from the object at higher level to the charge to the object at lower level, and the flow continues till the level of the charge on the two objects become equal. So this action takes place in very small fraction of second, but as long as charge flows, This is known as electric current or electricity, the flow of electron, right? So it is electricity which makes your computer, television, toaster, different machines, etc. work. It lights your bulbs, torches, runs your mobiles and calculator. The various type of electric cells provides a short term supply of flowing electrons or electric current. Now the question is that how to detect the charge? Detection of charge. So charge is detected by a simple device that is called electroscope. We will first make our electroscope. For that, we take an empty small transparent jar and cover the jar with the help of thermocol, and then we take a metal wire, or you can take the spoke of your bicycle whose lower end is bent to form a hook to pass through it, such that the lower end of the wire reaches half the height of the jar. And then we place a copper wire and we beat the copper wire to make it flat shape, right? And place on the hook of the metal wire, and we give a fold at its center so that it looks like a shape of an inverted V. Now what will we do? Firstly, we rub a plastic straw, charge a plastic straw by rubbing and quickly touch its rubbed end to the upper end of the metal wire in the electroscope, and then we observe that the copper metal which is bended and hanging in the hook. So we observe that the metal wires come closer, and remove the straw and touch the upper end of the metal wire with your hand. And note the copper strips falling back into their normal position. So by doing this activity, we observe that when we touch the metal wire with the charged straw, the charge flows through the metal wire to the copper strips. As the straw had high level charge and metal wire had low charge, so charge always flow from higher level to lower level, and the two copper strips acquire same type of charge from the straw. They separated apart due to the repulsion of similar charges. Same charges repel each other, and the copper strips were now charged. And when we touch the metal wire, charges from the higher level, that is the copper strip which have high charge, flows to the zero level charge, that is our hand or our body. Therefore the repulsion experienced by the copper strip vanishes, and that's why it doesn't repel now. So the process of removing the charge from the charged object is called discharging of the charge.